Once. Yeah, still don't know how to read this. Okay, and then we'll go move on with lightning talks. So the first question of the day is, who's got some lightning talks for today? I know the queue usually is super long, but maybe not this time. Okay, disconnected is as always prepared. All right, and then before 9 p.m. we'll just move on to the after party. A little bit more about this in a few. Today, we'll be eating, feasting on pizza thanks to Bartek, poker faceowaty? Poker faceowaty. Big thanks to you. Do you want to like share some word or something? Go on. This is the link where you can find CV.
Thank you.
This is the shortest sponsor presentation ever. That's like a record. Okay, and also thanks to Disconnected, we have drinks or something. There will be in a few minutes. They're also delayed a little bit, but they will be here in a few minutes. So don't worry. Thanks a lot, Disconnected. Yay. Okay, another sponsor. Brains. As usual, we have activation codes for their software, so you can win one of these. How to win it, you will see in a minute. Old slide. Thanks to Klug for the presentation, and apparently I forgot to change one slide about the Cosmo PK, the place where we are. So big round of applause to the people who organized the spot for us. Yeah. All right, join us. You can check out our website, pykonik.org. We are organizing Pykonik every month. We try to organize it every month, and usually we do. And join us on our Discord. It's at discord.pykonik.org. Every discussion is happening out there between the meetings. You can learn there, you can share there. And also you can take part in the competition to win the activation key for the JetBrains software. In order to do that, just go to our Discord. I will repeat, discord.pykonik.org if you are not there yet. And there's a channel called Pykonik76. This is the place where you should place some interesting fact, news, something you have learned recently about the technology we all love. So it should be related to Python, but can be a little bit wider than, broader in the area than Python itself. And the person with most reactions under, or rather the most people reacting under this shared message will get the code. I hope this is clear. And yeah, after party. So as usual, we are going after these presentations and lightning talks, we go to the after party. This is super close to here. It's like 100 meters at most. So we'll be at Infusia as usual. So who wants to join today? Okay, it's like 25, 30%. We'll try to make these numbers grow. But meanwhile, we'll start Pykonik and we'll start with presentation from Overflow. I guess you're ready. No, we don't have to. You have to wait 8 minutes. Let's give us like the 2 minutes and then we'll start, okay? All right. So if you find out that you want to do some lightning talk, oh, right, small advertisement about lightning talks. So if you don't know what a lightning talk is, it's a super short presentation that should take up to 5 minutes. So it can be only 1 minute if you wish. And it should be something you want to share, something you want to show. It may be some new library you have recently found out. It may be some project you are working on, some open source code, whatever, or maybe some initiative that's happening around and you would like to spread the word. So yeah, this is what lightning talks are for. I will be asking between the talks and so on. If someone wants to do the lightning talk, you can even jump on as the last one on the queue, even during the lightning talk, so no worries. All right, so we will start in a minute. All right, a short break. For Overflow and his presentation.
Testing. 1, 2, 3. Okay. But I think they cannot. All right. If everything's fine with the sound right now, let's start. So yes, there's a library with a very peculiar name in Python that allows you to do very strange things. The second title for this talk, I think, should be called like this because, you know, your code has the right to identify as error-free whenever it wants. So yeah, we were talking about this library. Actually, 2 Pykonics ago, there was a lightning talk about it. It was showcasing what this library was able to do, and everyone had a laugh, but no one really thought about how it works underneath, what's going on, that it does the thing it does. Janusz, could you please come here? And I wanted to do that. So to show you what it does, basically, and how it does. Well, if this library was a meme, then basically that would be it, because it steamrolls all the errors that you have. I'm sorry, Pwndbg, could you please start the timer so that I know how much time I have? Thank you. So basically, what is it? It's a library that steamrolls, as I said, all the errors in your code. Whenever, regardless of what you write, it will run. It uses a combination of various solutions to do that. It uses semantic versioning. I mean, sorry, I always mistake those. Semitic versioning, and it's currently at this version. Yep, I'm serious. That's the current version. It is licensed under the what the fuck public license version 2, and it's available at this address, and it should not be and sadly it should not be confused with the fuckit py package on PyPy. Because, well, that one is another one. It's a completely different one, and sadly, what it does. It modifies the files on your drive while you are running your code. So really make sure that you run this one. Anyway, let's show how it works. Basically, let's say that you have a file broke. Can you see it, or maybe I should. Is this okay? Ignore. That's the way we do it here. So we have a function that has some broken code. We have this. We have that. You know, lots of stupid stuff. And we have the example file that imports it. That has some. Some decorator, sorry. Some decorator for broken functions, decorator for classes. It even has some with clauses, and somehow it still manages to work. So now if we do uv run example, yeah, it does work. So what's going on here? Let's go. Where's my presentation? Yes, it's here. So yeah, anyway, as I said, we had a laugh 2 Pykonics ago, but instead of merely watching this, we should ask ourselves a question: is something like that even possible? And as our mentor from the History channel says, yes, it is. So we will go through the code. First, we have the context manager. Basically, if we use it with any code, it will basically enclose it in an exception, and whenever the exception is fired, it doesn't do anything. So this is the simplest thing that we have. We have the enter and the exit function, or rather method, for our module. And basically, what it does is whenever we are entering a with clause, the enter method is being run. In this case, it does nothing. And when we are exiting, the dunder exit method is being run. In this case, what we are doing, basically, we are checking if there is an exception. There has been an exception or not. If there has been one, we just basically return true. And we are checking for the exception here. Not the base exception, because we don't want to
ignore the keyboard interrupt or system exit, which is basically when you're pressing Ctrl+C. By the way, this is the code that I have slightly modified because the whole library, it works both for Python 2 and Python 3. So to make it clearer, I've removed all the Python 3 code and made some small changes to make it easier to understand. Anyway, we want to import something, a module. So instead of importing it the regular way, we basically just fuckit. We call it with the fuckit method, and then we can call functions from that module. How does it work? So first, don't worry, I'm going to go line by line. First, we find the module, then we check if the module is of type source, and then we do other things. So, find module. Well, the first problem is that it's deprecated, so it won't be working in Python 3.12 and later. But for now, we'll just go with this. Don't worry. So, anyway, how it works? It finds a module with a given name and gives you a few things. It gives you a file, a path name for that module, and the description, which we don't really care about besides the type. The type because we want to know if we have access to the source or if this is something that's been compiled or a C extension. And now what? Oh, I could. No, sorry, I won't have time. If you want to know some more details, hit me up later or after the talk at the after party, for example. Nowadays, for Python 2.12 and 13, and actually earlier as well, we are using, instead of using the imp module, we use the importlib module with along with finders and loaders. What they do is first we call the findspec function with the name of our module. This will give us a module spec, and then we pass that, and then we check the loader of that module spec and get the source. This will basically give us the source code of a given module. I could say a lot more about this, but this topic is actually a topic for a whole presentation. So I'm going to have to pass on this, but yeah, this is how we do it if we would like to do it nowadays. So what we get in the end, we get the source file here, and we check the module type. We check if this is the source code, and if it's not a source code, if it's just something compiled or anything like that, basically we cannot do much. So we just import it and do it and close it in a try except close, because since we don't have access to the source code, we cannot do much. And then we return a dummy, and if that fails, we will return a dummy module here. We'll come back to this later. And then there's this strange thing. What does it do? Well, basically, what we have here is we have the access to the module inspect for Python. What it does is as the name suggests, it inspects all the objects. It can inspect objects in our code, and in this case, we access the call stack. The call stack gives us a list of frame info objects. Basically, whenever we have a function call, we are adding some frames. We are adding some frames to the call stack. Each frame contains things like, let me show you there. The frame object contains things like the code that's there, all the local variables, all the global variables, etc. But in this case, we only need the current locals. Yeah, so this is also some old code, so we could simplify it a bit by adding access to the frame here instead of, you know, this one. So anyway, what we do is we get the stack, then we get the first frame, because the 0th frame is the one that we are in. Basically, whenever we are in a function, the 0th frame is the current frame right now. And the first one is the one of the color of the function. And then what we do is we access the frame, the frame for that stack, and then access all the local function, the local variables, and we just assign the module to the local variables. So basically, whenever we call fuckit our module name, what we're doing is actually we assign the variable of that name in the scope above. So for example, let's say if I open Python, what we can do is whenever we want to, we can access those things. So we have a function that that does this. So we do with me inspect stack 1 0. What was the thing? F locals. Yeah. Not victim, but in this case, var name equals content. So right now, for example, if we want to access a variable that's called foo, we don't have it. But if we call the function fun, if we call our function fun, sorry, not fun, but foo, it should be here. Oopsie, sorry. Oh, yeah, you're right. Sorry. Thank you, thank you. So again, we recreate the function. What the hell? What's going on? We recreate the function, and now yes, this one. And now, if we access the variable, it's magically here, because the function created a local variable in the stack above. So this is what we can do in Python. Now, let's go. So, so yeah, what we let me check. Yes, we were going to. Yes. So basically, what we were doing is we got the function, and we got the module, either by importing it or by creating a fake module, and then we put it in the local variables for the color of the function. Then next thing is the else clause, which I wrote here by basically changing the equal sign so that it's easier to read. So in case we have access to the source code, what we're doing is we get access to the source file. Well, we just read the contents of the source, and what we do, we first call compile. We create a fake module. We fill in some values for that, and we put it into the sysmodules dictionary, and we execute the code. Again, let's go line by line. Compile. What does it do? It takes some source code with several arguments, and basically it compiles the source code to compile object either into code or an abstract syntax tree object. We can give it a file name optionally, and the mode and I don't really know what's going on with that mode. If anyone knows what the difference is, it would be nice to, if you said so, because I actually read the documentation, and the documentation says that it compile differs depending on what you pass in. But for me, when I was testing it, I don't know, it seemed to work the same way. So maybe someone here knows why it doesn't change anything. That would be nice to tell me. Then we execute that thing. Basically, as you can see, there's a warning in the documentation, so don't really do that. But if we want to fuck it all, we just have to sometimes. Anyway, it allows us to compile and execute that code and to get all the side effects. What we do here is we pass it either the compiled source code or the text of the source, and we pass a dictionary. A dictionary that will then be filled with the local variables that have been created while executing the code. So, for example, again, if I have a dictionary that's empty and I execute some code, like for example, a equals 42, and I pass that dictionary, what I will get is, if I print the dictionary, there will be a lot of code, because if we take the keys here, we will have the built-ins key that's been added automatically. That's where we have all those built-ins, like, I don't know, zip, property, int, list, map. Those are all built-ins that we can pass by ourselves, but otherwise we will get those from the built-ins module automatically. And we have our a value. So if we check, what's in there, we have that value again. So yeah, basically what we're doing here, we are executing the code and ensuring that all the local variables that have been created by the code that's been executed land into the local variables of the module. Let's go further. So yeah, and also we create the types module. So this is actually, this is not really much to say here. If you have a module type, you can create a dummy module that doesn't have anything, whatever. And it's a module that basically doesn't really have anything that you have then to fill in yourself. But we can do that. We can create modules from scratch just by putting together a few lines of code. So this is one part. And we are doing that in a while true loop. Why? Because there may be some exceptions that happen because the code may be faulty. So what's there? Oh, and by the way, I almost forgot. Do you know how Python ensures that circular imports don't happen, or rather detects circular imports? Does anyone know?
Probably checks whether the name of the module is in sys modules.
Exactly. What happens, I don't really remember the specifics, but we have that import sys. We have the sys modules attribute. Modules attribute, and actually, again, keys. These are all the modules that are imported currently. So we can, whether I'm accessing sys or I'm accessing sys modules of sys, we will get the same module. And it works the way that, in this way that whenever we are importing a new module, Python first creates an entry in sys modules with an incomplete module, and then proceeds importing all the other requirements like goes into that module and execute the code that may import some other modules, that may import some yet other modules. And then if there is an import that is a circular import, which means that it imports the first one, it will go into sysmodules and notice that, hey, this module here, it's not a module that's fully initialized. And then that's how you get the exception that says that there is a circular import, because we have that special kind of, or rather, that uninitialized module already in sysmodules. So this is done on purpose. So then, yeah, we have that while true, and what happens if the exception, if any exception is fired? Lots of code again. So first, we have this strange thing. First, we have this sys.exeinfo function that is being called. What it does, it gets the current exception information in the form of that tuple that contains the type, the value, and the traceback. And what we want is we want to get the traceback. That's why we get the second element here. And that traceback, we pass it to the extract_tb function. That extract_tb function gives us a stack summary object that we then access in some strange way. How exactly? Wait, so that shouldn't be here. Anyway, I think I'm missing a slide here, but anyway, what it does is we get a stack, and we want to access the last frame of that stack, because we want to get the line number. So that's why we access the -1, the object at the index of -1 to get the last line, and then we get a stack summary, and that stack summary has a few. I don't know why it's not here. Maybe there's a slide. Maybe they are out of order. But anyway, the first argument should be the line number, and we get it here. We get the line. Afterwards, we use a getAttr to get the line number from the exception. I'm not fully sure why it does that, but my guess is that sometimes the exception will have the line number, and sometimes it won't, because maybe the exception is a special kind of exception created by the programmer. So then we will get the line number attribute value, and if that fails, due to how the getAttr works, we will get our extracted line number from the exception. Then what we do, once we know where the exception happened, I don't know what's going on with my mouse. Sorry. What we do is we get all the lines of the source code, and we check that line and simply remove it, because why not? We don't need it. It doesn't work anyway. We join all the lines again, and then we go back to the while true loop, where we will try to again. What's going on? I don't know what's going on with my slide. Sorry. Again, we go through the compile exec loop as long as there's any error. Once there are no errors, it executes and it assigns the value, the local value here. All right. Then we have the class decorator. Basically, it makes use of the regular decorator, which I will talk about later. So even though it may look a bit complicated, it basically just goes over all the members of a given class and checks if we have a class, a function, a lambda, or a method. And if it does, it basically attaches itself as a decorator to that member. Basically, it adds a decorator to all those attributes, all those function calls, all those subclasses, etc. And the regular, the regular decorator, it does some strange things as well. So we have, I'm quite sure I've modified those slides. I'm sorry. For some reason, that's strange. Because I don't see things that I've put here. Anyway, we have the, what we have here is we have the inspect, again, the module. In this case, the get source method is being called, and what it does is it just gets the source code. Sometimes it returns an error, but as I can see, this module, I mean, the fuckit module, doesn't care in this case for some reason. But what we are doing is we are getting the source code of that function method or whatever it is, and then we remove. This is not really important here because what we're doing is basically we are removing the indentation because for some reason the code that we are being given does have this indentation, and we will not need them. It's later. What I don't understand is why they don't use text wrap didn't, which does precisely that, but maybe they want to make things more complicated. But you know, at this point, I believe them. But I believe that they are doing the right thing because, as you can see, they really know what they're doing. Anyway, in case there is an error here, what we're doing basically is we are just adding a regular decorator that just does a try and accept. And if there's an exception, we just do a pass. This is in case we cannot get the source code, for example, or any other error. It really does, you know, a best effort way of fixing all those errors. And then we return the wrapper. If there are no errors, so we go to the else clause. So we basically we manage to get the source code for our function or class or etc. Well, there's still a few things to unpack here. So we have our fucker that we want to visit. It looks like this. Don't worry, I'm gonna go again line by line, or rather chunk by chunk. What we have here is we have a node transformer, a class that inherits from node transformer. The node transformer, I mean, or rather, the AST module is the abstract syntax tree module. What it does is basically it creates a tree that contains all the code that we pass to Python. Whenever we want to compile the code to get the compiled code. Before it does that, it creates an abstract syntax tree that we can then modify, for example, before compiling and getting the compiled, not the pseudocode, but I don't remember the name. Basically, what's being interpreted by the Python interpreter. And we can do it by ourselves and modify that code before we compile it. So we create a class that inherits from node transformer, and then we can create a method, either visit something, like for example visit name, if we want to act on all the names in that tree, or a generic visit, that we use today. And what this does is that it basically is called with all the nodes from the tree, and then whatever that function, the generic visit function returns, it's being replaced inside that tree. Afterwards, we have the fix missing locations and copy location function being called. Those aren't really important, but I'm adding them here for completeness, because basically, whenever we create something, we need to ensure that all the values are here, like the line locations and some other less important things that we don't care about, but the compiler does. So basically, we can just use those utility functions to fill them for us. So anyway, let's go back here to the node transformer class. We have that generic visit callback that calls this the original method, which allows us, to go downstairs, let's say, down the tree, and call itself for every node of that tree. If we have a statement or a function, then what we do is we create a new node that it's a try except node. Basically, what we are doing here, we are enclosing like literally every single smallest thing inside a try except close, so that we can, if anything happens, we're just not doing anything. And basically, after that, we have that node. Yeah, we copy the location from the original node. Basically, this copies the line number, the character position, etc. And we return that node. Once we return that node here, we get the tree that's being fixed. For some reason, it removes the decorator lists. I don't really know why, but I'm guessing that this is because, well, it was messing with something. I didn't really check thoroughly this, because this is probably something that they decided it's the best to do. That they want to strip all the other decorators. I don't know why. And then, yeah, they fix the missing locations for the whole tree. They compile the tree that they got. We already talked about this. We create a new dictionary that we use to execute the code to get all the locals, and then we return that all those locals to that to the general global scope. And that's basically all that code does. So what did we learn about today? We learned about all those functions. We learned about the find module function, the find spec, and the loader. We learned that we can create a dummy module. We can inspect the stack of a function, of a function being called. We can get the source of a module, of a function. We can compile code dynamically. You can execute that code. We have the modules. Oh, I didn't talk about the meta path. The meta path actually is whenever we are using the finder and loader here to create our own loader for Python in general. Whenever I am here, we have the sys metapath attribute, and what it contains is finders for several built-in finders for Python. What they do is whenever I'm importing something, doesn't matter actually because it won't find it. Whenever I'm importing something, Python goes through the metapath attribute and goes through all those finders and asks all those finders, do you know anything about this module? Can you handle it? So for example, if we want to import built-in, I think it was built-ins. Yeah, you will get the built-in importer that will say, "Hey, I know it. I can handle it." And if you want to create your own finder and loader, then you just add it to the metapath here, so that whenever you are importing, your finder has the chance to react. Basically, you can do things like, for example, dynamically get code from Stack Overflow if you want to. Anyway. We have the, we checked the traceback function, and we also looked at the abstract syntax tree. So this is what we learned about today, but what have we learned? Is that Python has a lot of ways to do code introspection. It allows you to do code modification easily, but, your coworkers also have lots of ways to hurt you if you ever use those. So it's good to know that you can do things, but there are things that are better not done, especially not in production. And basically, that's all I wanted to say today. Thank you. I'm out of here. And I mean, do you have any questions?
Before you're out of here, questions? Okay.
Maybe one question, one comment. The question, I think you kind of already answered. Have you ever shipped it to production? And if so, how quickly you got fired? But I guess you haven't.
Of course I have. That's the first time I got fired.
And the other is more like a comment. So I wonder if on one of the last slides when there was a decorator, they are removing the list of the older decorators, and I think
wait, this one.
I think it's further where there is the decorator, the wrapper of the function.
Wait, where is it? Wait, I'm sorry, I was going up.
Yeah, it was one earlier.
Earlier?
Yeah, actually, it's not that important. Basically, they're removing the list of the other decorators.
No, that was in.
Yes,
that was
they do delete.
In the fucker, yeah.
So I wonder, because I know that if the fuckit decorator is not the most outer one, the first one or last one from the list, it could like break it. But I think maybe it would make sense to reorder them so that the fuckit decorator is the most outer. I'm not sure if you know what I mean. But
that wouldn't.
Because if we delete them, their code is never executed. So basically,
I know
we are only wrapping the actual function without the previous wrapper. So maybe there is a possibility to have the issue on their GitHub and to improve their code a little bit, or maybe there are some other problems that they already thought out and it wouldn't.
We will never know. We will never know. Actually, there are a few other things. Because, for example, in their code, they have, how do they close this? In their code, they have, for example, this. It doesn't work in Python 3, but it worked in Python 2. There's such a line, for example. And I was really tempted to say that we could give a PyCharm license to anyone who finds what it does.
It says what it does.
But I'm not sure if we can do that, but yeah. Yeah. So let's say that if anyone goes besides the reaction, that contest that we have on Discord, if anyone goes there and the first person who writes what this line does, actually, yeah, we'll get a PyCharm license. You cannot win. Okay, so do you have any other questions?
So I was wondering, if you go to the terminal and you do sys.meta path equals empty list, will you be able to import anything?
It should break, I think.
So you cannot reassign it, or?
You can.
I mean, you can do clear, right? But you won't be able to import anything, right?
Yeah. If path equals this, if I do imports, I don't know, OS, for example. This probably was there.
This still works. Maybe you had it.
Yeah, I have it already. For example, I don't know, traceback, I think.
Traceback, yeah.
Traceback. See?
Yeah, makes sense. Thank you.
Because normally what you do is you insert your own finder either at the first place or at the last place, so that's it's being run executed besides all those default importers, unless you want to. For example, sometimes this is being used when you want to have a self-contained Python installation, and you want to ensure that you handle all the importing. Because, for example, you have all the modules inside a there's a zip importer, for example, so that you can import everything from a zip file, or you can, for example, have it, I don't know, inside a DLL, inside the memory. This is what PyOxidizer does, by the way, which allows you to create an executable file with Python embedded, and it makes sure that everything that you import, it gets it from the executable, not from the outside environment. And I think that it does it by changing the meta path, but I would have to double check that.
Any other question? Okay, then. Big round of applause for Overflow.
Thank you.
Thank you very much. And pizza's here. So, yeah, time for the half-an-hour break before we move on with the presentation by Disconnected. Maybe a little bit less than half an hour, but still. So, yeah, bon appetit. Okay, you ready?
Yes. If
You're
this
ready.
works, I'm not sure if this
Everyone's ready? Piotrek? We're good. Okay, so without further ado, disconnected on Pwndbg. Big round of applause.
Yeah, so welcome everybody. I'm Disconnected, and I will be talking about some kind of my journey to like open source development and maintaining of this project called Pwndbg. For those who do not know, Pwndbg is an open source project on GitHub. It's on MIT license, so it's free and you can use it even for like commercial stuff. And it's actually a plugin for GDB and LLDB for security research, exploit development, reverse engineering. So yeah, I will tell more about it later. A few words about me. My nickname is Disconnected. I'm Dominik Czarnota, apart from that. And I play CTFs. Those are capture the flag security competitions. And that's where I actually started to use Pwndbg, and then eventually I'm maintaining it for a couple of years already. And I'm also working in security for a company called TrailBits. I'm a staff security engineer, so in my day-to-day job, I'm like auditing software and finding vulnerabilities and helping fix them, basically. So Pwndbg, what and why. As I said, this is a plugin for GDB and LLDB. Those two things are GNU Debugger and LLDB. I'm not sure if there's like a shortcut for it, but basically those are debuggers for native code, so like for programs written in C, C++, Go, Rust, and even like some embedded stuff, and a bunch of other languages probably as well. And the thing is that those debuggers are usually a bit bare bones. So for example, if we would run something like GDB over a program called, for example, ls, and like, start the program, we see kind of nothing. We started ls on its very first instruction, and we see nothing. We don't have the source code for ls program, so we don't really see the source code, but we can still debug it. We can still, for example, dump the CPU instructions that are there on the assembly level. And we can step over it with some commands that are there included. So I'm jumping over the next instructions right now. I can, for example, display the register status with inforeg, I think. Yeah. So those are like CPU registers, and you can inspect those values and maybe make something meaningful out of it. But this is a bit bare bone, and those tools are very powerful under the hood, and even some IDEs use them there. Like, for example, in CLion, you probably have LLDB or GDB under the hood when you debug some of the stuff. Not necessarily Python, but if you would debug like CPython binary itself, the code written in C, then you would probably use GDB for that. And the Pwndbg is a plugin that initially it was started just for GDB, so I'll mainly focus on GDB here. I will tell a few words about LLDB as well later on, but most of my examples are from GDB itself. But basically, it provides a lot of features. So first of all, the main feature that it provides is like it displays some kind of context for you. And this context can also be seen if you type in context in Pwndbg, which will show you the context. It starts with legend, so there is some kind of information how you should interpret some of the colors that are there. And then it shows you like a bunch of stuff, right? So there are multiple sections here, so we'll go over them. So first of all, we see the CPU register values. This is a bit, colorful, and there is a bunch of information here, but we'll go to it later. Then you have some disassembly of the code, so you can see where you are in the code. And you can display this with GDB, but with this context display, you can see it all the time. Then you have the source code, if you have it. It can also be source code fetched from some other tools if you have some kind of decompiler synchronized with Pwndbg, which can be done. And then you have the stack display. So usually programs use some kind of stack memory. So this stack memory is being dumped here for you. So you can see its values because that's usually useful. And then there's backtrace. There can be some other sections here, like, for example, about threads that are running in the program, and some others that can be enabled with some other commands. And this also can be reconfigured if you want to just see, I don't know, disassembly or maybe just source code. Then you can reconfigure it and work with that as well. The other main feature that is there is like telescoping stuff. So when you're coding in C or C++, we have this thing called pointers. You have this like int star 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 that is like and like multiple stars that is a pointer to some other pointer. Then it can point to another pointer and so on and so on. And eventually you can point to an int, for example, like in this picture, right? And when you have those kind of pointers, you probably want to display them somehow, or you want to know that this value that you see in the program is actually a pointer. And this is what this telescope feature gives you. So for example, if we have some C code like we can see here, that we have some kind of error structure on the top, and then we have this error structure on the bottom. This error structure has actually 2 pointers, some message and some callback. And then if you do telescope over this pointer that we have here, you will see actually that here's the address of this pointer. Then it points somewhere on the right to this E object that is there instantiated before it. And then this E object is actually here in this memory dump. And so you can see this object in here. Yeah, so for example, you can also see that this div by 0 string is actually located in here on this right side. It's being commented out because like this looks like code, but it's actually not code. But we have this notion when something is read, it means this is probably some code that can be executed because it is located in the program section that can be executed. So that's why we also display some kind of assembly instructions for it here. Another feature that we have is actually displaying nonlinear disassembly. And what do I mean by that? So, this should be this one here for this No, I think I'm missing a slide. Yeah, this is this one. So in your code, you may have some kind of jumps. Your code may jump somewhere, and those jumps may be conditional. So for example, here we have this JE instruction. And it says it goes over some kind of address, that it will jump into some address if some condition is met. And this condition is actually, encoded in the instruction itself. It's called jump if equal, but more precisely, it's like jump if some kind of 0 flag is set in the CPU. Now, what is the 0 flag? The 0 flag is set in the special register of the CPU called eflags that we are actually displaying here for you. And you can see this ZF flag is there. It's in the red color, so it means it's not really set. So we know that we are actually not taking this jump. So now we are displaying you basically the next instruction after this jump, because that's where the program would go. But if this flag would be actually set, in this case, like we can even set it manually with the set flag command that we have in Pwndbg, then we would actually show you some kind of arrow that we are jumping there, and then we would disassemble the instruction that where the program is going, like non-linearly, because previously the disassembly was like linear. The next cool feature that we have, and I need to come back here, is we basically predict some values that are there in the program. On the left side, you can see there's this first column with addresses of the instruction. Then you have the disassembly of the assembly instructions of the CPU. But on the right side, you have all those weird things like RBP and some arrow, or RSP and some arrow, or this flags on the bottom, and so on. So the thing is that we are actually emulating instruction into the front, into some kind of, for example, up until a jump instruction is found. And we are fetching all the values after each instruction, after emulating each instruction, and we are enhancing the view with those values. So now you can know that if we execute, for example, this test instruction here before the jump, then the eflags register will look like this. And for example, if we do the sub RSP 1000 instruction here, I'm not sure if you see my mouse. Yeah, you can see it. Then the RSP will have this value, because here's its previous value, and we will subtract 1000 from it, because that's what the sub instruction would do to this register. So we are doing this one with emulation, and for that we use some kind of native library called Unicorn Engine that allows us to like instantiate the CPU, put the code into it, put the memory it needs, and then run the emulator. So we basically emulate the same instructions that will be executed at some point. And we are displaying those values. That's one thing. And second thing is sometimes we know statically that what would be the value, because like if there is any instruction that sets some register to value 0, then we basically know that the register will have value 0. So we kind of know it, right? Yeah. Yeah, we also display function arguments if for some of the functions that we know the API for those functions, like system calls or some glibc library functions. Like here's this write function that is there in glibc. It takes a file descriptor, it takes the buffer pointer, and the number of bytes that you want to write. So here we see that the file descriptor is 0, so this is probably standard output. And here we see the buffer, and we see what's the string under it. And we see the number of bytes is 0xc. This is in a hexadecimal, so this is, I think, 13, if I count correctly. Yeah. And we do it, whenever we know the function the API for the function. We also have a proper hex dump because, like in GDB, you can dump memory, but this is a bit. Maybe I'll do this. Like for example, you can dump memory, using this X command with some format here and the number of items you want to dump. So for example, we can dump it like this, but this doesn't really show us, the bytes itself. We can also dump, like maybe 100 bytes, like 1 by 1. But this still doesn't really show us like a proper hex dump, which may be useful because you want to know that, I don't know, the value of 48 is H letter, for example, or that, here is some values that are actually like some environment variables, for example. So this can be helpful, and we have a command like this, and it's all written in Python because this Pwndbg is written in Python, and yeah, we implement this. We also can show you like the memory mappings, the virtual memory mappings of the program. This is something that like GDB and LLDB has. Well, LLDB not necessarily, but GDB has this command called info-proc mappings. But this is a bit worse because like in GDB, they don't do any coloring. Info-proc mappings, if we do that, you can see those memory mappings, but you don't really know the exact permissions right away. Sure, you have the column here, but we are doing the coloring for you, so you know that whenever the color is red, this means this is the code section where some executable code is stored that can be executed by the process. So this can sometimes be useful when either debugging or trying to exploit some vulnerability in the process. And as I said, a lot of stuff can be configured. We have some commands for that, like config or team. So there's one for controlling like colors that you can see, and there are lots of things like how many number of lines of disassembly code you want to see in the context, for example, or what sections you want to see in the context display, right? So all of this is configurable, and yeah, there's plenty of configuration here. And there are many more features that I haven't really showed you here. Like for example, this is actually something I want to show you. So I have a Firefox here being launched, and if I run now GDB with Pwndbg, so probably with sudo, because if I want to attach to the Firefox process, I need to probably be root. Yep. We are in Pwndbg now. It's being loaded under the hood, and now if I do attach p, this is our command, like attach p Firefox. So I'm now attaching to Firefox, but well, Firefox has like 10 processes, so I have to choose which one. We can show its command line on the right side, which is a bit, not full here, but still. So if I try, I don't know, the 8 number, we can now see, that we actually are debugging one of the Firefox processes here, and we can see what is happening here. It's actually waiting on something. It has 11 threads. Only 4 of them are displayed here, and you can see more of them if you type in just threads, for example. So we can see, the name of the threads that are there and where are they. And with normal GDB commands, you can switch between them as well. But what I wanted to show is that you can actually do a command called procinfo, and this will show you a lot of information about the process taken from the proc file system. So for example, here you can see that some SE Linux group. I think this is not SE Linux. I think this is a parmer. Maybe this is a bug. I'm not sure. Maybe this is SE Linux. I'm not sure. Like a policy for some kind of security stuff. You can see the command line, but what is more interesting is you can see all the file descriptors that are opened by the process. And if you would inspect this process normally, by the way, file descriptors means like all the files that are opened by this process. You can inspect it in this proc file system with the process identifier. But if you do it normally, this is a bit different. Probably a bit less information is shown here. Like for example, for this FD1, we only know here that this is like a socket, but we don't really know what kind of socket this is. And here we kind of figure this out, and we say to you, hey, this is a Unix domain socket. It's anonymous socket. If that would be like a TCP socket connecting to some server, because well, Firefox usually use TCP at some point, right? Then we would see here like TCP and the IP end port for the server. But unfortunately, I think we didn't get a case like that. It's interesting that Firefox also uses a lot of like memfd. This is like kind of mapping anonymous memory in the process, like anonymous files in the process or something like that. But yeah, it has like 56 files opened right now. Interesting. We also have like a bit better search for memory than normal GDB, because like in normal GDB you have this find command, which is very awful to use. You need to tell it the range of the addresses you want to search between, but you cannot use like search from address 0 to the infinite address or to the last address possible. You cannot do that because it will exit at the very first address it cannot read. So instead we have like a search command. So I don't know, I can do search and then maybe GitHub and look if there is a GitHub string in the memory of the process. And there is, because I actually opened the GitHub page in the Firefox process. So there are multiple strings. Well, actually this is some library, so maybe I'm not sure what this is, but there are many cases where there is like a GitHub string, and I can even like hex dump this now and inspect what is there, and I can see there is some DevTools string there, whatever. We also can inspect the glibc heap allocator status, and this is helpful when you have some kind of bugs with glibc heap. And there is heap command for that. I'm not sure if this will work here. Yeah, I think it won't, but maybe we can try to do that. And maybe it will, okay. This doesn't work here because Firefox is probably not using glibc heap, or our heuristics to resolve the heap didn't work, to like resolve the heap didn't work here. But with normal programs it would probably work, but yeah. And there are like many other stuff. Even like if you, for example, want to, you sometimes have a case. I know you may not be used to it, but there may be cases when you want to exploit some process and you want to find, like for example, on stack memory where there are pointers to some exact memory region. So for example, I have this address of the stack memory here, and I can do something like Pwndbg and put this address and 1000, and I can see that, hey, on this offset from that address, there is pointer to some anonymous memory allocated by gemalloc, and the address of this is this, and this is an offset from this gemalloc allocated page here. So this can sometimes be useful. Yeah. So this was about like features of Pwndbg. There are many more. As I said, there are lots of commands. And for example, if you do Pwndbg, just type in Pwndbg, you can see all those commands that we implement. There are, for example, commands if you are like debugging a Linux kernel for fetching some stuff from the Linux kernel memory. You can even patch instructions. So if you want to change a jump instruction to do nothing, for example, you can patch it with a no-op instruction, for example. And yeah, there are plenty of those. So yeah. And oh, by the way, there are also some commands if you want to navigate between your process, like maybe you want to step over instructions up until some syscall is called, like a system call. So we have a step syscall instruction. It shows a bit bad output because it shows each instruction that we stepped over, but eventually it stepped over the syscall instruction and stopped on it. And this is something we don't control because this is something GDB displays and you cannot truncate it. So yeah. So there are cases like that because we don't modify the GDB C++ code. We only write the Python code with it. I also want to say a bit about the Pwndbg history because I maintain it from a couple of years. But actually, it wasn't the first plugin like that for GDB. So like in 2012, someone created PEDA, a guy called LongID. And this is something that's not really maintained anymore. It had like last commit was like 5 years ago, but it looked pretty similar, right? And it was just a simple Python script with like one Python script with, I don't know, a few thousand lines of code that was there and just did it logic. Then there is GEF. This is actually another product like Pwndbg that can be used. It's still maintained, and it's also a single Python script with no dependencies. I know there's some extras that you can install with dependencies that can add more features to it, but it also looks pretty similar to Pwndbg. The commands are pretty similar. Some of them are different. Like, I don't know, I'm not sure what exactly right now, but I know there are features that are there in GF, which are not in Pwndbg, but there are also features that are in Pwndbg, but are not in GF. But Pwndbg was actually a fork of GF created in 2015, made by a guy called Zach Riegel, who passed away, unfortunately. And the idea was to basically take GF and split it into like Python modules and have it, more structured code and maybe include dependencies as well and have more features eventually. And this is what it is basically. It's like multiple modules of Python and a lot of different dependencies that do a lot of stuff. And by the way, I actually started contributing to Pwndbg in 2017. I don't remember when exactly I took over the project because eventually I started contributing more and more. And the guy trusted me and like gave me some permissions on GitHub to, for example, merge pull requests. And then I was maintaining it more and more. And then I eventually became owner of the project. And interestingly, there is also another project called Bata24GF, which is another fork of Jeff, which has lots and lots of features that are not there in Pwndbg. And it's also like a single script. But yeah, it didn't take, there are not so many contributors to it, but it's sometimes useful. Here are some random statistics. We have more than 8,000 stars on GitHub. I don't know if that is any kind of metric, but it's still more than the other projects. We have more than 900 forks, if that counts at all, because people fork projects on GitHub just to send a pull request, or sometimes they fork without doing anything. But there were times where people forked it and added some features for just themselves and never contributed them back. So there are some forks that have more features, but not that many, and they are not really maintained. We had more than 200 contributors, as you can see, and with contributors, it's always I can say we had that many contributors, but most of them sent like one pull request, right? And we have more than 300 Python files, 80,000 lines of code, 10,000 command lines, and here's some kind of statistics graph over time. Each column is 1 week. We had a week when we had more than 100 commits. I don't know why, but we had so many. Yeah. And here are some random statistics from last month. So for example, we merged 77 pull requests, which I'm kind of amazed. I don't really remember all of them, but it's kind of a lot. So there is traction going on, and there are people who are contributing all the time. And as you can see, we had like 18 authors that contributed in last month. Yeah, here are some more statistics. We had 10,000 Git clones in last 2 weeks, 3,500 unique of them. So this is pretty a lot, I would say, and almost 4,000 unique visitors on the repo over a 2 weeks period. So I'd say the project is kind of successful and it's kind of used in there. And coming back to like my first contribution, it was in 2017, as I said, and it was like I was fixing some bug that was there. Like, I tried to use some command that was implemented, but it didn't work, as you can see, and I just changed one line because some path of some file was changed and it was never fixed in the code eventually, and there were no tests at that point. So yeah. And now I want to go over some various aspects of maintaining an open source project and some random stuff out there in Pwndbg. So first thing, when you maintain a project, it's not so straightforward how to get people first to use it, and second to actually contribute. It's very untrivial, especially with a project like that, which is kind of complex, and it's not a simple Python module, which I'll go over later on. And I don't really have, an exact description what you should do, but basically, I guess it's good to have a good setup, which now we have that. We didn't have that for a long time. It's good to have good docs, which we are working on it, and UX, basically. And it's always hard to also teach people how to use your tool if this is like a plugin for GDB. Like, how do you find new commands? How do you know how to use this specific command? Like, it's very non-trivial how to teach people how to use that. We also have some tips added. So, like, when you launch, wrong password. When you launch Pwndbg, you will basically see some random information about it, like what you can do, like, oh, there is context pref and context next commands to display something, right? So we are displaying some kind of tip of the day that may teach you something about the tool. And if you don't want that, you can disable that as well. It's also nice to organize some workshops or coding sprints. I have done that a couple of times, once on EuroPython and a few times here in Hackerspace Krakow. So I was advertising this on Pykonik Discord and also on the Krakow Hackerspace. And by the way, on one of those, we had a blindfolded person who actually came with some, I think it was Mac Mini with some headphones, and he was able to read the source code, and he was even able to contribute to the project, which is kind of amazing if you think about it, because like you have to get into the project, like clone it, kind of learn how to use it first with a super fast reader of everything that is displayed on the screen. And we use colors here, so this is not trivial, I would say. And we also take part in Google or Python Summer of Code. This is like a project from Google where open source project can come in, and you can tell, oh, we have those mentors that can mentor or supervise some kind of projects, and people who want to contribute can come and they can earn money from Google contributing to your project. Of course, there is some format for all of this, and this is actually will be taking place soon. It's nice to have a good Git workflow, but I would say instead of good, just keep it very simple. And this is what works for us. We initially had like 3 branches, dev, beta, and stable. But the question is, how do you work with dev, beta, and stable if people just take dev branch and just install from dev branch all the time, and they don't really care about stable or beta? And that's one thing. And second thing is you have to manage this beta and stable branches and maybe backport some fixes sometimes, and it takes time. And nobody kind of, okay, now we have GitHub sponsors, but previously nobody paid for this project, kind of. So, this didn't work, and now instead we have just a dev branch instead of master or main, whatever. And we have just releases made out of the, one of the commits of the dev branch when it makes sense. Easy setup on installation. This is a cool topic because, as I said, Pwndbg is not a normal Python module. You cannot really install it with pip. You cannot do pip install Pwndbg. Although I would maybe try to support it. Maybe this is doable, but most likely it will end up saying to you that, hey, if you want to install Pwndbg, go here instead of using pip. The thing is that, since we are integrating with GDB, you need GDB, and this GDB needs to be compiled with Python. It's always compiled with a specific Python version, so you cannot just, write your Python script in a random version. It has to be working with this version that you compiled GDB with. And we had a setup as H script, which we still have, and it looks like that. It goes over and tries to detect your distro on Linux. And if you use apt, it will install apt. If you use Fedora, it will install DNF, and so on. So you have installers for the dependencies. And the question is, at the end of the setup, it will do pip install requirements. Now this is using UV, so some UV sync or UV install, whatever. And then at the very last thing, it will just do this echo with the source GDB in it to enable this in GDB. Now the question is, does this make sense? Do you see any problems here? Well, if you're missing a distro, that's one thing. If this is Ubuntu 22.04 versus 20.04 versus 18.04, all of those versions are different on each of those, which is really pain in the ass if you think about it. And this was pain for a long time for us, and we were like, oh, we support from this Ubuntu version. And we are testing only on this version. Now we are testing on multiple versions as well. But the thing is that, and another problem here is that we are installing some dependencies. But hey, who is the user of, I don't know, some libglib 2.0 minus dev? If you don't have like a program that uses it, I think apt will tell you, hey, this is probably an unused dependency at some point, and maybe it will uninstall it if you do some cleanup. I don't know. And also keeping track, of all those versions is really hard. So this is just a best effort installation. Like, I'm not saying that Fedora will work all the time and so on. So yeah, this was me, right? Trying to wake up from this nightmare at some point. And I would like to thank here Cipis, which is another maintainer of Pwndbg, which helped with this a lot. And if you never heard about it, there is this package manager called Nix, and it's awesome. And the thing is that I'm not going to show you Nix here, but because like Cipis came and took basically Pwndbg and created this Nix description for the package for Pwndbg, he made it so that now we are building like distro packages for each of the main distros that are there, and you can install, you can download deb or rpm or apk and install it. And this will be a Pwndbg program. And the thing is that this package contains fucking everything. It contains GDB, Python, all the Python dependencies, all the native dependencies like Unicorn Engine or Capstone that we use. So we don't really care about whatever GDB version you have on your distro. We just install you the latest one that is there in our package, right? With Pwndbg. So now you'll have probably 2 GDBs, but who cares? And with that, we can always be on the latest, and we can always use the latest versions, which is not necessarily true. We also support a bit to the back, but still. And we also have portable builds, and this is nice because, well, we have portable builds for a lot of different distros, architectures, as you can see, for both GDB and LLDB, and also for Mac OS. Because now we support it with LLDB support. So this is pretty neat. And this portable archive also contains everything in there. But interestingly, if you would, I'm not sure, I didn't try it, but we can try it now. So on macOS, if you download the portable archive and you try to run it, which I will try, need to do it from the console. Will it actually? Not this terminal. iTerm. What? Wow. This is not great, but okay. Oh my gosh. You cannot do -R here. Yeah, so we have this, for example, Pwndbg LLDB for macOS. If I try to run it here, it will tell me Python 3 not opened because Apple could not verify Python 3 and blah, blah, blah. It can be malware. What do you have to do? You have to go to some privacy settings or wherever, or some security settings, and you have to tell, OK, Python 3 is cool. You click that, you rerun this, and then you rerun it, and then it will tell you, hey, there is another thing that is not secure. And it will tell you for every fucking library that is included in this. Because that's like a Mac OS quarantine that is there if you download an archive and unpack it with a browser. If you download it with wget in the terminal and just unpack it, it should work. Because the wget is not setting the quarantine for the archive. So to fix that and also to provide yet another way of installation, we created a homebrew package. So you can install Pwndbg with brew as well. And what it does eventually, well, first of all, it downloads the portable archive, and then it will remove the quarantine from it after installing it. Because Homebrew is actually also setting the quarantine just for you to remove that. Another topic is like testing, right? It's good to test stuff. And no tests, no failures. I started contributing when something was failing because it was not tested at all. And we actually have different types of tests. We have like unit tests, we have tests for GDB and for QEMU stuff, and we use PyTest everywhere. So we have some unit tests, but there's not very much, and we have some mocks being done because like for unit testing, we have to mock basically everything that is there in the GDB or LLDB logic, right? So this is kind of painful, and we only have a couple of unit tests. But for example, here you can see how this looks like. It's pretty straightforward and easy to write such a test, right? For GDB tests, we have a fixture called start binary. So basically, for each of the tests that we have for GDB, we will run a separate instance of GDB process to load some binary, to execute some GDB commands on it, and to execute some Python stuff there. And here's this fixture, and here's, for example, a use case of it. So as I said, we start a binary. In this case, we have some try except, which I think can be removed. Then we use this magic GDB execute command, which allows you to execute any arbitrary GDB command from Python, like set a breakpoint or continue up until some point. And then we have some assertions being done. In this case, like grabbing some data from Pwndbg and seeing if this is the expected value. In this case, basically. Yeah, we have also QEMU tests. So for those who don't know, QEMU is a program called QEMU, Quick Emulator. And this is something with which you can emulate either normal programs from different architectures on Linux, or you can emulate, with QEMU system, you can emulate like a whole kernel. So you can emulate like a Linux kernel, and you can create like a virtual machine using QEMU. You can also use KVM, which is hardware virtualization in the CPU, but let's not talk about it. And we basically have some tests that will, use QEMU to spawn like a Linux kernel virtual machine. And then this QEMU also supports a thing called GDB server, so it exposes as like a GDB server that GDB can connect to. So we connect to it from GDB, and then we are testing something this way. Yeah, and I also wanted to say something because, as I said, Pwndbg is a plugin for GDB, right, or LLDB. So how is this done actually? So for GDB, we are, we are using what is there in GDB. We are using the normal GDB program, and we are hooking into its API because it exposes some hooks. And you can actually also, source. There is this source command to execute Python scripts, or you can enter Python interpreter, and you can use this GDB module that exposes different stuff for you, different functions. For LLDB, we are not launching LLDB and using scripting. LLDB also exposes some kind of native C++ API to Python. So we are just using this API, and we have our own REPL. So this read eval print loop that is a console thing. And I will show it in a second. Oh, and by the way, since GDB is not so richful in its API that it exposes, sometimes we have to do so bad thing like, oh, something equals gdb.execute, execute some GDB command, and then parse a string. Because GDB does not expose, this command actually allows you to ask GDB what is the programming language that the binary was written in, because GDB can auto-detect it. And we have to parse this string now to get this information because there's no API in Python for that. So please fix if someone wants to contribute to GDB. And in terms of how it's done on the C or C++ level in GDB, they use the standard C API, CPython API for creating modules. So there is some kind of structure for it. And there's this Python GDB methods that is basically telling all the methods that are there. So for example, if you want to use gdb.breakpoints attribute in Python, it will execute this function that creates a list using the API, iterating over breakpoints that the GDB knows about, and just returning this as tuple. So some of the code there is pretty straightforward. Some is not that straightforward. Like how is this all breakpoints implemented? This is written only in C++ there. Yeah, and for LLDB, as I said, we implement our own REPL. This is more or less how it looks like. So we take input from you, and then we execute command. Now, we do some smart parsing here, which looks like that. I have a question for you. Why do we do it that way? Any ideas? Like, we want to support the version command, but we check for the version string this way. So if constant literal version starts with the line, or if the line starts with VE. The thing is that all GDB and LLDB allow you to type in the command, not all the command. You don't have to type in all the version. You just have to type in VE or VER or VERS. So in order to support it, that's how we parse it. And so we have plenty of code like that for parsing some kind of, because we want to provide the same interface that is there in LLDB. If you know a better way to do that, please tell me. Because, this looks weird, at least it starts. Oh, and by the way, when you're maintaining such a project, eventually you will find yourself in a situation where there are not so cool contributions. Like, for example, people are sometimes spamming like, hey, can you assign me to this GitHub issue that is there? And I can say, okay, but eventually the guy is doing nothing. So I stopped doing that. Instead, I am all just saying, hey, just send a pull request, right? Because I don't care if I assign you to an issue. We are not a company. We are not paying you or anything. So, just send me a pull request. Just send me the code that, implements something or fixes the bug. Actually, the second guy that wrote here actually implemented the thing that was there. And also vibe coding, right? Today we got a pull request like that. Fix team initialization in init.py. Huh? Is there any bug? It says, there's some testing being done and this is ready to merge. Please review and suggest changes if needed. The change was like that. I mean, there were more lines, but it all looked like that. So from constants, they moved the constants into some dictionary and then used the dictionary retrieval instead of the constants itself. How does this fix anything? So what I did, this is not, there is no my command, but I answered that this is not a fix and this is spam. And I closed the pull request and I reported the guy on GitHub because why are you sending me this and why are you wasting our time? And also, the money from GitHub because we are using GitHub Actions for free. So, yeah. Yeah, and I also have some random stories. This is something I already said on one of the lightning talks before on the Pykonik, but we have this py command, pa command for launching Python interpreter, but I also have an IPI for launching IPython interpreter inside of GDB, and I also sometimes have IPDB, so this is like a better Python debugger. And the thing is that when I had IPDB installed, I found out that my GDB with Pwndbg is starting much longer. And I noticed that if you do 2 files like that and you time how much it takes almost half a second to just import IPDB. So I reported it to them, they didn't fix it, so the kind of issue is still there. But instead of always importing IPDB, I moved it into some later place in the code to import it. So now this is not really an issue if you use that. Yeah, and this is all for my slides. I can probably say a bit more, but the question is, do we have time? I think not necessarily, yeah. So that was it. We also have GitHub sponsors if you want to help us with money or something, or buy us a coffee. This is not really, this is not really paying off at all. We don't really have much sponsors, I would say, and we definitely work more hours on it than people pay us for it. But yeah, I would recommend you trying Pwndbg, and maybe if you want to contribute as well. I know this is not straightforward how all this works and how that can be maybe useful if you're just a Python developer, but maybe you have some use case to debug something on a low-level way. Yeah, so thank you.
Thanks a lot. Now time for questions.
So a quick one, not about the project, but about their users. Do you know what's the most regular profile of the people that use Pwndbg?
Yes. Capture the flag competition players. So, because on those CTF competitions, you have two categories. Okay, there are multiple different categories of challenges, but there is reverse engineering and there is binary exploitation. A lot of those challenges are on Linux, and Pwndbg works on Linux, now on macOS as well. So people use GDB or Pwndbg to debug stuff or to try to exploit programs or develop exploits. So that's one thing. Second thing is like standard security research. I had maybe 2 cases where I had to use Pwndbg in my work because I usually have source code and don't really need to debug on such a low level. But there were cases where I had to, and I don't really develop exploits at work, so as well, this was not needed here. But yeah, you can use it for debugging low-level problems. Yeah. I was also after one of the CTFs, I was also trying to like develop some feature or actually fix a bug in QEMU, in this program for visualization. And I was using Pwndbg to debug it because that was helpful.
On the slide where you mentioned parsing commands,
Yeah.
I wanted to ask about this. Because if you thought about it, then I want to ask why it didn't work. What about pattern matching?
Oh, yeah, sure, we can do pattern matching, but it'll be slower, right?
Oh, okay. That makes sense.
Yeah, I mean, probably depends how you code it, but I guess the regular expression module in Python would be slower. Maybe not, I'm not sure, but probably would be slower. And this is a bit problematic because if you would have 2 commands that starts with the same letters, then you may end up having them in a wrong order with this prefix match. So this is something that you have to do carefully. But yeah.
Okay. I guess that's it. So once again, thank you very much. And we'll move on to the lightning talks. Do you want to do it right away? Or
I'm not sure if I have lightning talk yet.
Ah, all right. Okay, Bartek.
But I can come up with something.
So we have at least this one. You have 2. Okay. No, just do it. Just set up the computer. Does anyone else have a lightning talk? Okay, 2 more lightning talks last minute. Actually, this is just the right amount of time we have for lightning talks, so this will be perfect. Okay. Tak. Włączyć chyba musisz jeszcze. To od razu 2.
Od razu 2?
Od razu 2. Dobrze. Okay. So 2 lightning talks from you.
Right. So I have 2 of them. Who knows what turtle is in Python? Okay, I expect less, but okay. So story time. I needed to plan my balcony, and my balcony is pretty specific because it's very wide and very narrow. So I wanted to plan how the furniture fits in, and most importantly, if it fits in, because I know particular elements are enough to fit, but I don't know how they all come together. And when my mom heard this story, like just me stating the use case, my mom and I said that like I didn't want to just redraw them every time with a pencil and then like erase them all the time. When my mom heard that, she said, "Yeah, I planned a house. You just cut them out from paper." And this is the first time in this story I felt like a complete idiot because no, I didn't think about cutting them from paper. I thought about writing a program, obviously, and that will take me 3 times as much time. But either way, I discovered that I wanted to write. If you read like the C programming language or pretty much any other programming book, I guess, but the C programming language is a good example. Then there are some examples there where they try to write like real world programs, but you always think that like I would just use something else. Like the actual Bible has I think converting, like getting numbers from standard input and then converting them between Celsius and Fahrenheit, you're like, I would just Google this. Like, okay, it's fun to do it. And then I realized that this is exactly an example like this. I can actually do it with a program like this. And after half an hour, when I printed the first output and a square wasn't a square, I realized drawing something in the terminal where the the letters are longer than wider, not the best idea. And this is the second time in the story I felt like a complete idiot. But anyway, I started researching how to make very simple graphics in Python, and I came across Turtle. And Turtle is a library which originally was made in Logo, which was a programming language in 1967, and it just consists, in layman's terms, it consists of a turtle that makes lines, and you can make the turtle write lines and then turn. So what I used it for, I think I have a demo here. Yeah, so if you just want to see what is Turtle, we can... So yeah, so what you can do with Turtle is just you make it go forward, you make it turn with just providing an angle, and then you just make it go places, I guess. That's the easiest explanation. And then what I wrote here, you can actually do it like this. What I wrote here emerges to... do something like that, right? So basically, you just tell the turtle it should come back. There we go. You just tell the turtle to move in certain directions. And what it helped me with was, if we now go and see what I actually used it for, is this is my room planner, and it's a very simple program where you just input the name. Like if you just make it draw, then this is my balcony, right? And then I want to add a table. And the table has to be at position 10 by 10 centimeters, and then the size of it is like 60 by 40, let's say. Now we can list all of the elements that are in there, and if you redraw, there we have our table, right? It also can write in different colors, but all of it is very simple, but it actually helped me, which is not very common with the ideas I have for Python programs. I usually find myself like 4 hours in going, no, fuck it, let's do it manually. But this actually helped me plan my, my balcony. And just as, so if you ever need to, the consensus is if you ever need drawing very simple images, then you can just use this library and not worry about like any dependencies because it's built in. Batteries included, as always. And to end this, I have kind of a surprise for you, and it's this. Oh, you can't see it, but it's still drawing. If you're thinking like whether I planned this, as in like, you know, I put this in ChatGPT and told them to tell me how to write all the instructions, or did I just bash my head against the wall until it worked? So second lightning talk, huh? So yeah, that's one thing, and the other is kind of inspired by what Disco said in Discord once, and that's just pinging me on an article called Self-Hosting Like It's 2025, and this is a great article in general. I believe that like when I was starting self-hosting, I would love to read an article like that. Unfortunately, I didn't across an article like this, and it resulted in some very nasty bashing my head against the wall. At least I learned something from that, but like, yeah, I would love to see an article like this. What this article covers is basically, hey, it's 2025, and there are a couple things that are pretty good with self-hosting. And it also, it doesn't go to the extreme of a thing Omnicore once said, which is the single distro rule. If you're explaining Linux to someone and you want them to use it, but like nicely explaining that it can help them, but you're not trying to absolutely make them use it, you use the single distro rule, which is you show them Linux and then tell them, hey, this is Linux. You don't ever mention that there are different distributions. This is for like advanced users. If you show your grandma Ubuntu, Ubuntu is now the only thing that ever exists in the Linux universe. Just like that. And it's something that many of the Linux enthusiasts missed. Like if you explain to a new person what Linux is, just pick a distro and go with it. So this doesn't go to extremes like this, but what it does do is it shows you a couple of tools that are useful in self-hosting in the year 2025, but it also mentions that like this thing is more advanced, read about it more, this is a lot more text config and less GUI. So it explains Docker, it shows Podman, but it says just like, if you don't care that Docker is a company, if you don't care that like some parts of it are not open source or whatever that is, then just don't use Podman, it's whatever, but it's just like, it's mentioned. It's mentioned what it is. Kubernetes is also, like Kubernetes is kind of a stretch because like, if you're a beginner, this should be skipped to me, but whatever. Anyway, there are a couple interfaces that can help you. The one I've been using for forever has been nginx Proxy Manager. Caddy is here, and Caddy is carefully explained that I wouldn't recommend it for complete beginners, but if you appreciate simple Unix-based tooling, Caddy is an excellent choice. So if you're a complete beginner, you just wouldn't use it, but you know about it, and that's great. Anyway, I wanted to show that, like, that's very true. Self-hosting in 2025 can be very nice. And the other part is I just wanted to show a live example of how you would spin up a self-hosted service, and most importantly, how easy it is for most of them. So let's say we're skipping research and choosing a tool because how they demonstrate that. So if you go to Awesome Self-Hosted and look up Navidrome, let's say it's Navidrome as an example, it's a music server. So you can spin up your own music server. And if you go to the Navidrome page, you have installing with Docker and using Docker Compose. And Docker Compose, I mean, if anyone has ever used Docker, then whatever I'm saying is very obvious. But either way, if you haven't, then Docker Composes are just very, wait, I'm the right folder. Docker Composes look like the default is, what am I doing? I just pasted the default, and then in the default, you usually have to set something up, but it's usually pretty limited. You don't have to do a lot of things to spin up a service. So in the case of, if we just open the Docker Compose default, and then wait, not like this. If we added Docker Compose I actually used, then you can see that I only changed with the default example, I commented out the environment because we're not using it, and Docker is going to throw an error if we're not using anything in the environment part. And then I set up the volumes. So basically, I'm linking folders inside the Docker container. So like instead of path to your data, it's like an actual path with the folder called data that I made, and the actual path to my music. And the only thing that is there is just a single album. Right, so now the only thing that's left to do, and that's how most of service launching looks like in self-hosting nowadays, is you just do Docker Compose up D, and as we all know, D is being quiet because D stands for Dobra Japatam. So if we just do this, there we go, Docker Compose D, it starts. The only thing I did beforehand was download the image because it's a couple of 100 megs and I don't have good internet here. But if we just go to localhost 4533 now, that's Navidrome. And that's it. And in most cases, when I'm adding a completely new service to my pool, one thing that I've never seen before, it's just like, it's usually just Docker Compose up with like 3 lines changed because most of them are pretty standard. They don't expect you to do anything special. And yeah, if you like underground Polish hip hop, then this is a great album that I obviously ripped from the vinyl that costs 1,500 zlotys, obviously. Either way, yeah, so pretty obvious for anyone who has ever used Docker or is a DevOps, but I just wanted to prove that like self-hosting in 2025 is pretty easy, it's pretty damn fun. So yeah, that's it. Thank you.
Zobaczymy po Gandhi. Tak, Gandhi, bo ty jeszcze masz. Ty masz. A. To zobaczymy.
Hands-free czy nie hands-free? Myślę, że taki wystarczy. Jak już się podłączy. A, tu jest. Czy to jest to, co ma być tam? Dobra, czyli działa. Tak, to możesz już... Jeszcze nie. Możesz już przełączyć. Hi everyone. I would like to. So I have two short announcements. One is actually, since you saw the talk by Bartek, if you go to meetup.com and if you keep scrolling and you scroll all the way to the sponsors, and then you zoom in, you will see that Bartek is actually a sponsor of today's drinks. So round of applause for Bartek. And the second one, which is as always about EuroPython. Who knows what EuroPython is? Okay, by now most of you. So the short announcement, if you go to the website and you go to the schedule is up now. So you can go to either tutorials or the talks, and you can see exactly what's happening this year between July 14th and July 20th, plus the sprints. So yeah, and that's it from me. Go to europython.eu.
That's good.
Hey, did you know that we are going to an after party today? In like 20 minutes or so, or maybe less. So I just wanted to show you that this is how it looks like. You really don't have to drink if you don't want to. This isn't really even a party. It's more like a continuation of the discussion here. If you have something to discuss, you're welcome to come there. And also, if you're worried about wasting your time, you are here. Infusia is here. It's 150 meters, and if you check it, like the direct line is 15 meters. So you can waste 2 minutes of your life at most, and you can go check how it looks like. If you don't like it, then you're welcome to leave, but at least give us a chance. And also you will be then able to figure out what this line is doing. And also I figured I'd give a hint, or maybe not. Maybe it's a hint, maybe it's not. It's being mentioned when porting fuckit to Python 3. Someone said that the assignment dereference won't work in Python 3. And eventually the author said that, well, he merged the pull request. And he said that as for the reference assignment, that he wasn't able to reproduce the race condition. So that he made it only for Python 2. So now have fun with that.
One more lightning talk, but before that, a small announcement. You have the lightning talk, right? Small announcement for me. You can still post to the channel Pykonik 76 on Discord to win in the competition the code for JetBrains software. Tak. Co jest? Tak. Yeah. One important note is that the code for JetBrains software now includes it is for the pro version, which includes the AI, whatever it is, like assistant, which is the feature which was separately paid up until the recent version release. So now it's included in the pro version. So basically, it's worth it to try. Because that way you can create these cool vibe coding PRs for disconnected Pwndbg, so he can block you and report to GitHub. So
Please do so.
okay, so one last. So go to the channel and post anything you learned recently or found out recently. Grab this code. I recommend it. And now the last lightning talk of the day, right? Right. By disconnected.
Second thing is, if you heard about a tool called Vermin, this is a tool for Python. This is like a linter that will try to detect, I think, the minimum Python version needed to run code. We used that in the past, but it doesn't work with the latest Python versions. So if you know other tool that works that way, or maybe you want to contribute to Vermin and fix it, please do so, because we would like to use that more. That's one thing. Second thing is I wanted to show you another thing of maybe not vibe coding, but GitHub actually have this Copilot feature, right? And you can actually request Copilot to review your pull requests, and we do so. Oh, and by the way, we use CodeCov, which I usually don't care about, but we have it. And I actually asked Copilot now to review 2 pull requests, and here are some comments like, hey, maybe here you are comparing file data directly to some string, and this is error prone because maybe you should want to strip it. I have no idea if that makes sense, but we'll have to look into that. And here it found a typo. In another PR, it said that this is okay, although it said some comments with low confidence. NumCMD to more descriptive names. Okay, whatever. Is this something I wanted to show? No, probably not. Maybe? No. We also use MyPy, and we have it on like CI/CD, right? But the thing is that you can also enable some kind of annotations that like MyPy can annotate your GitHub code reviews with, hey, here's the issue that we did that. This is a pretty neat feature. We don't do it for all the CI linting, but we probably should. And yeah, that was it. And I have the stickers if you want. Yeah, thank you. Oh yeah.
Okay. I guess this is going to be it. Actually, I don't know if I should do the ending presentation because basically Overflow did some part for me and Arthur did some other part for me. I mean, this is awesome. Yep. Yep. All right. Wrapping up. I'm picking up my phone to check. Okay. So first things first, thank you. A round of applause for our sponsor, Poker Face Waty. I'm leaving it for a few more seconds for better positioning later on in the YouTube. All right. Thanks also to Disconnected. We stayed hydrated thanks to him. All right. Now, thanks to the JetBrains, just a short clap. And to Cosmo PK for the spot. And to Kluk, to Piotrek and others who helped us. Yay! Thanks to them, you can watch us online, but it's better to be on site, always. We have more funny things happening here when we don't stream. Right? Am I correct? Yes? Yay! But still, being online is also important, especially between the events that we have. So go to discord.pykonik.org, join us on the channels and join the discussions, and especially join us for the competition. So now I'm gonna officially check the results. and looks like that the most reactions are under the post from Vlad. Vlad is here. Yeah. Do you want the code for JetBrains software? Yay! Congrats. So we have a winner. Actually, Vlad found out. Oh no, I'm not gonna tell you what he found out. Just go to the channel. Yes, go to Discord. Now, who's going to the after party? Since now you know where it is, and actually since it's like 150 meters or 50 meters, so average is 100 meters, so I wasn't wrong when I told you 100 meters in the beginning. That's nice. So let's go to the after party. Thank you for today. No more slides. Nothing more from me today. And see you next month, probably on the next Pykonik meetup. See you around.